Hey AP Physics 1, this is Horner, and we're looking at 2008 AP Physics 1 free response question. We have a drinking fountain. It projects water at an initial angle of 50 degrees, so there's an angle above the horizontal, and the water reaches a maximum height at 0.15 meters above the point of exit. We can assume that there's no air resistance here. Derive an equation for the speed of the water as it leaves the fountain. So what they want to know is how fast is it moving in this direction? So they want to know about how fast is it moving in that direction. So that would be V original. And at this point, we can kind of think about the X and the Y direction. In the X direction, your V is constant. Okay, so that is a constant value. In the Y direction, your velocity does change as time goes on. But we know a couple things. We know that if we think about the velocity in the y direction, we know that at the very top here, the velocity in the y direction is equal to 0. So that's really the final velocity in the y direction. And the original velocity in the y direction should be a number bigger than 0 because we've got to have some way for it to go up. So the question is, what is the original velocity in the y direction? And that would be this side of the triangle. So let's go ahead and make our triangle. This is the original velocity, that's what we're looking for. And then we have a 50-degree angle, and we have two sides of our right triangle. This is the opposite side, here's the adjacent. So this side would be the original velocity in the y times, oops, that would be the original velocity in the y, but we want to say it's actually just the original velocity times the sine of the angle, and that is equal to the original velocity in the y. Let's start with an equation. We know that the velocity in the y, the final velocity in the y, squared is equal to the original velocity in the y squared minus 2 times gravity times height. So that's one of those kinematic equations that we used earlier. At this point, we know that the final velocity in the y, we said earlier, was 0. So this goes to 0. We don't need to worry about it. And now our equation is the original velocity in the y squared is equal to 2 times gravity times height. So we just added this to both sides since this side is 0. Now that we know that, and we know that the original speed or velocity of the water coming out times the sine of the angle is equal to the y velocity, we can substitute in this equation here. So we're going to say the original velocity times the sine of the angle, and that whole thing is squared, is equal to 2 times gravity times height. So we want to get rid of the square, so we're going to say VO times the sine of the angle is equal to the square root of 2 times gravity times height. And we want to know what is the original velocity. So we just want VO, and that's equal to the square root of 2GH all over the sine of the angle. So this is our equation. Notice that we're using VO, and that's one of the things they told us we can use. We're using H, that's another one. And we're using sine, that's just a function, so we're good there. We're using theta, that's just a constant, so we're good there, and 2. So we are done with this very first part of the problem. The next thing that they want us to do in this problem, and we'll just go ahead and move this down, it says using your equation from part A. So here's our equation from part A right here. They want us to calculate the speed at which the water leaves the fountain. So now we can plug everything to our equation. So the original speed is equal to the square root of 2, and here we're going to use 10 this time, just to change it up. And then we know that our height was 0.150 meters, and we're going to divide that by the sine of 50 degrees. Make sure you are in degrees on your calculator and you're not in radians. If you solve this, you should end up with an original velocity of that water of 2.26, so this should be 2.26 meters per second. And that is your final answer. So where do the points probably come from in this? There's probably 3 points. 1 of those points is for having this original equation, 1 point for your final equation here, and then 1 point for the correct answer with the correct units. You do need to show all the other work or they might not give you all those points, so you just have to be really careful. So that one is a mere 3 points, and that's all you get for it.